And now we're going to continue our discussion of derivatives, and I'm going to tell you a little bit more, and then later on I'll tell you even more than that. But let's go into, we plugged in the number 5 to this equation. If you'll remember from our last video, we have s equals 16t squared. Alright, we plugged the 5 in for this t right here. We squared it, which is 25. We took 25 times 16, and we got 400. So, over a period of 5 seconds, a golf ball dropped 400 feet. Okay? From the top of a building straight down, it dropped 400 feet in 5 seconds. But it doesn't mean it dropped 400 feet at the instant of that 5th second. It means over a period of 5 seconds, it dropped 400 feet. We want to know at this point what its instantaneous speed was at the 5-second mark. Now, how are we going to find that? Well, that's where things get a little complicated. That's where we have something called the derivative. Okay? Now, can we find instantaneous speed? Eventually, yes. But it gets a little complicated. Let's say we're trying to find out how much distance the ball travels between the 5-second mark and the 6-second mark. Well, you say, well, we could just subtract 576 from 400 and find out how much it traveled between the 5th and the 6th second. But yes, we can. But let's take that 5th second between seconds 5 and 6 and divide it up into 10 equal parts. So now we have 5 seconds, 5.1 seconds, 5.2 seconds, 5.3 seconds, so on and so forth. If we plug in 5.1 into t squared right here, and we solve the equation, we get 416.16 feet. So in actuality, between the 5th second and 5.1 seconds, the ball has traveled an additional 16.16 feet. That's a lot of movement in a 1/10 of a second. Alright? Now if we plug in 5.2 seconds into this equation, we find out that the ball has traveled 432.64 feet. So it traveled 32.64 feet between the 5th second and 5.2 seconds. That's a lot of traveling for 2/10 of a second. And we can go on and on. 5.3 into this equation, and we get the result of 449.44. That means that the ball drops in 3/10 of a second. It drops 49.44 feet. That's a lot of distance. Alright, but what we're trying to find out is not how much the ball dropped in 3/10 of a second or 2/10 of a second or 1/10 of a second. We're trying to find the instantaneous speed of the ball at the 5-second mark. And that's where we're going to start with our derivatives. Okay? And I'm going to tell you the rest of this in a future video, so stay tuned.